1942 orthophoto shows this as a meandering stream. When we look at the 1962 orthophoto, we can see that the river was straightened and bermed. By removing this berm, we are allowing the river to regain floodplain access, which will allow it to meander over time.
Hello, my name is Shayne Jaquith. I'm the River Restoration Scientist for the Vermont River Management Program. During this segment of the video, we will be discussing and showing you examples of river floodplains and meanders. We will start with a look at how and why floodplains and meanders develop over time, and why they are so important to the maintenance of channel equilibrium. We'll then explore how floodplains and meanders have been altered by humans and how those alterations have affected channel equilibrium. And finally, we will discuss how Vermont is working to restore river floodplains and meanders. So what is a floodplain? Floodplains are those flat, low-lying areas alongside rivers that are flooded during normal high water events. A floodplain begins as an in-channel deposit or gravel bar. As the river moves away from the floodplain over time, it deposits sediments on top of the bar, and the bar grows in height. In a river system that is in balance with its watershed, the growing bar will continue to build in height until it is at the approximate level of the ordinary high water. In Vermont, the ordinary high water event typically occurs during the spring snowmelt period. So the floodplain can be thought of as a large pressure relief valve. What is the pressure relief role that floodplains play that is so important to channel equilibrium? When we dredge or mine gravel from a riverbed, when we build berms, or construct roads or other infrastructure along rivers, the river becomes disconnected from its floodplain, and all the tremendous power of a flood is concentrated within the river channel. Let's take a closer look at a couple different river channels and their floodplains to get a better sense of why river-floodplain connection is so vital to channel stability. Here we are at a location along this river that has great access to its floodplain. Because of the good access to its floodplain, this river is able to maintain channel stability over time. As we can see, the floodplain at this location is no more than 3 to 3.5 feet above the riverbed. What this means is that during high flood events, the water rises to this elevation and then spills out across this vast floodplain. This in turn means that the depth of flow during even the highest flood events never gets greater than approximately 3.5 to 4 feet. This has the effect of maintaining or regulating the stream power in this channel during even those high flood events to maintain channel stability over time. Here we are at another location of the same river. At this location, the channel has eroded downward over the last 20 years, losing access to its floodplain. During flood events, the water depths can reach 8 to 10 feet in height, generating tremendous amounts of shear stress that easily transport the material from the bed and banks of the channel. This is a very unstable condition, and the river has eroded rapidly over recent years. This is exactly what we mean when we say a river is in disequilibrium or out of balance. The downward erosion of this channel is a result of two primary factors. The first is the historic practice of dredging or mining gravel from the riverbed to prevent flood flows from spilling onto the floodplain. This practice has caused separation of the river from its floodplain. The second factor is a change in hydrology of the watershed that has come about due to development that has increased the impervious surface. These surfaces include parking lots, rooftops, and other non-permeable surfaces that cause the water to move directly to the river channel during rain events. The cost to Vermont communities incurred as rivers lose access to their floodplain is significant. Now that we've learned about the importance of floodplains, let's explore river meanders. So what are meanders? Meanders are the curves that are common in many of Vermont's rivers. They are formed as the river erodes sediments from one bank and deposits them along the other. This naturally slow erosion and deposition process is caused by the flow of the river as it corkscrews down the channel. It's not easy to see, but as water flows through a channel, it doesn't actually flow in a straight line, but rather flows in a spiraling or corkscrew fashion. This spiraling characteristic of the river flow is a natural process that has been shown to persist in even the straightest channels and laboratory flumes. Thus, no matter how straight we might try to make them, rivers will always tend to meander. This can be demonstrated using a simple river model.
A lot of our streams begin to move from a straightened section to a meandering section because the water is actually kind of spiraling down through the channel. It also has, you'll notice, sediment moving through it, which will kind of bump and trigger as it's deposited in the area. Right. I mean, you can see from our original kind of, initial setup where we wanted the river to stay, it has moved and changed within those locations. The flume is a great way of just kind of demonstrating how sediment moves, how the meander process will happen even in a straighter channel.
So as the river model shows, straightened rivers will always return to a meandering pattern. Reviewing historic evidence such as photos, maps, and river management records has shown us that a majority of Vermont rivers and streams have been channelized, a process involving dredging, berming, and armoring a stream into a straighter and steeper configuration. These channelization practices that started over 100 years ago to accommodate early settlement, roads, railroads, logging, farms, mills, and other human investments have been periodically maintained through the gravel removal, realignment, and channel armoring practices. As a result of all this channelization, many miles of rivers have become disconnected from their floodplains, thus losing their pressure relief valve. This has resulted in a tremendous amount of channel instability and increased channel erosion. Along the many incised rivers of Vermont, land uses including agriculture, residential, and commercial development and transportation infrastructure have encroached into the lands previously used by river meanders and floodwaters. These encroachments have prevented the natural correctional responses of meander adjustment and floodplain rebuilding that is necessary for those rivers to regain equilibrium. Researchers worldwide have studied the relationship between the size of the land area drained by rivers and the dimensions of those rivers. Vermont has conducted similar studies to develop equations based upon stable rivers in Vermont that allow us to predict the equilibrium channel and floodplain dimensions of a given river based on the land area that it drains. These equations provide us the necessary information to design and implement restoration projects that reconnect rivers to their floodplains. Researchers worldwide have also studied the meander patterns of stable streams and developed ways to describe those patterns mathematically. Vermont is using those mathematical descriptions to design and implement restoration projects that restore stable meander patterns to Vermont's rivers. We have also used information from these same studies to determine the width of the river corridor required to accommodate the meander adjustment processes that are necessary to maintain equilibrium. We are currently working with landowners, municipalities, and state and federal agencies to protect these important areas alongside our rivers in an effort to restore and preserve channel equilibrium over time.